Okay, I think it's 2 o'clock. We can start. Good day, everyone, and welcome to the 34th session of ADB's Green Roads webinar series. My name is Kay Patu. I'm an environment specialist at ADB, and I'll be moderating today's session. So before we begin, I just wanted to share a few housekeeping reminders. So this webinar is being recorded, and the recording, the presentation will both be available on the ADB Knowledge Events page. The link will be shared with you in the chat. To ensure a smooth session, we've muted all of the participants' microphones, but we will have time for Q&A at the end of the presentation, so I encourage you to please submit your questions at any point using the Q&A button at the bottom of your screen. So today's topic is focusing on decarbonizing freight transport in Japan. And this is a highly relevant issue, as we know that progress in decarbonizing transport system across Asia and the Pacific continues to lag, particularly in the freight sector, where demand is projected to grow significantly in the coming years. So against this backdrop, Japan's experience that will be shared with us today offers very useful reference. So today we'll look at how Japan has combined policy incentives, operator behavior, infrastructure innovation, to drive emissions reductions across intermodal freight networks. We'll also hear about this Autoflow road concept, an automated freight transport system that has been proposed by Japan's Ministry of Land, Infrastructure, Transport, and Tourism. So this system uses unmanned shuttle vehicles and conveyor-based cargo movement to enhance logistics efficiency and also consider sustainability. So it's now my pleasure to introduce to you our speaker for today, Professor Shinya Hanoka. He's a full professor at the Department of Transdisciplinary Science and Engineering under the School of Environment and Society at the Institute of Science, Tokyo. He also serves as an adjunct professor at the United Nations University Institute for the Advanced Study of Sustainability. Professor Hanoka holds a PhD from Tohoku University and has held academic and advisory positions in Japan, Thailand, and the United Kingdom. His research spans maritime transport, air transport, freight logistics, transport development, and he's also had extensive experience in advising transport and logistics projects across Asia and Africa. So, Professor Hanoka, thanks so much for joining us, and please proceed with your presentation.
Good afternoon. Thank you very much. So I'd like to share my slide first. Can you see the slide?
Yes, we can see your slide.
Okay. Thank you very much. Good afternoon, everyone. Before speaking that, thank you for giving me the opportunity to give a lecture about this green webinar, a green road webinar series, episode 34. Today's topic is here, decarbonizing freight transport in Japan, policy impacts, intermodal networks, and outflow road vision. And actually, my affiliation is Institute of Science Tokyo, but you may know the name, the Tokyo Tech, Tokyo Institute of Technology, because we merged the two universities, our university, Tokyo Tech, and Tokyo Medical Dental University 2 years ago. Now the name is the Institute of Science Tokyo. Okay, so move to the next slide. So before the lecture, I would like to show the research area and my research groups. Here is my poster. The ex-students give me the comic style, and our research area is transportation development studies, logistics and freight transport, and transport. And in my group, we have another assistant professor and research fellow. And currently in the 19 students and doctoral students and also master 10 and undergraduate. I started my research group in 2008, and until this year, there are already around 120 students, alumni, and majority, of course, is Japanese, but I have also supervised many other countries from Asia, like this country also in Africa. And my core research topic is logistics and air transport, but also I focusing on that transportation development study that means developing countries transport and logistics issue. And today's topic is between zero carbon policy and the logistics for this intermodal. That is one of my previous master students have been done in this research. So going to the background, CO2 emission transport sector in Japan is the second largest emission volume following the manufacturing. And manufacturing top and around 20% CO2 emission in the transportation sector. Among transportation sector, around 55% is a passenger transport, like personal vehicle, other passenger vehicle, and the passenger rail and ship. And another 45% is a cargo. And then in total, around 40% is the freight trucks. So trucks is one of the major emission transport mode from in Japan as in the freight trucks. Then Japanese government more than 20 years ago, they are considering the modal shift from trucks to the freight rail or ship or air. Air is actually a little bit different, but they're considering trucks to rail and ships. Then the recent around 9 years, the statistics. So modal share freight transport in Japan to be the two different indicator, tonnage and tonne-kilometers. So tonnage is more than 90%, around 91% is truck. And railway, waterway, and airway is minor things. And then tonne-kilometer, which means about 1 ton in how much kilometers in total. This is also truck is a majority, but the percentage around 55 to 57%. And waterway has normally using for more long distance freight transportation. That's why the share around 40 to 38%. So railway is still not so popular, 4%, and airway is very negligible. So one interesting trend in this figure, tonnage is continuously decreasing, and tonne-kilometer also decreasing. And 2020 is the year of the COVID-19. Of course, they have much decline. But after that, tonnage, again decreasing, continuously decreasing from 2021 to 2024. But in the tonne-kilometer is stable. Why this is happen? This is like more e-commerce becoming the small package cargo is drastically increasing in Japan. That's why it's the small size and the light cargo. So that's why tonnage itself is decreasing, but tonne-kilometer is a small cargo in the short distance truck is more frequently. That's why tonne-kilometer is still stable. And considering the CO2 emission, we should reduce actually tonne-kilometers. So it's still the serious problem from the CO2 emission from the truck transport. Then what about the situation, the railway freight transport in Japan? So tonnage case is JR Freight is the major operator, but also other private railway also operation. And the share of JR Freight is around 89% on a container, but carload mean like coal, limestone, cement, petroleum is a fuel case, the heavy road fuel. That can be operated by the other private railway. However, tonne-kilometer base, it's almost operated by share of the JR Freight cargo company. So the one of some specific location, for example, here, Hikorochi line, they are transportation the coal from some coal area to some factory. So it's a very short distance. So there are some specific company, but majority transported by JR Freight. Then next slide. Actually, JR Freight itself, they have a problem with the management policy. And before that, also difficult using services. So in the railway in Japan, schedule are rigid because they share the railway infrastructure by the passenger railway and the cargo railway. There is almost very few dedicated cargo railway infrastructure. That's why it is difficult to flexible to meet the demand shippers and increased risk of damage due to transport station or terminal. And another program, JR Freight Cargo Company, JR Freight Management Policy. So they have a decline operating revenue. JR Freight has been trying to survive by reducing the scale of its business. So becoming the scaler and focusing only the urban area, even though long distance between to urban area. That's why the declining about the scale network. Then they have created mismatch of needs of ship and railway transportation. Actually, the government proposed some possible solution: expand capacity, ensuring safe, stable transportation, improve information modernization, and replacement aging rolling stock and railway infrastructure, then container service level. But as I shown in the previous slide, the still railway cargo share is still very low. And what about waterway freight transport? Actually, Japan is an island country. So in freight transport by using the domestic sea is popular. And they have a separate from liner cargo and liner vessel and tramper vessel. And tramper is like high volume monomaterial industry for iron ore, for example. And the liner case, maybe container is popular, but actually rolling on, rolling off, Roro shipment also very popular because they don't need the facility. So directly some vehicle can enter the vessel. So Roro actually is popular because in the Japanese island it's connected the many routes. So so they have this is one of the example, the liner waterway in Japan. And then what about the like a hindrance, the bottleneck to the modal shift? So competitiveness. Actually, the waterway transport is a low cost, but in the highway expressway in Japan, in the nighttime, they have a much discount for using the charge, the highway, the using the highway charge. That's why the shippers or truck companies still continue to use truck transportation in the midnight from the midnight 0 a.m. until 5 a.m. They can use the much discount prices. So that is one of the cost competitiveness, and Shuei, which has reduction in operating tax. And then large number of small business. So industry dominated by small scale business in the shipping company. So there's no, actually in the overseas vessel container services, they have three big shipping company in Japan, but in the domestic shipping company is very small. That's why number of operations are decreasing year by year due to the extremely weak management base with very little internal accumulation of the capital. And it is another very serious issue about shortage of workers, about aging population. This year, Japanese government showed the average age in Japan is 50 years old, finally. So the average of 50 years. So the very aging population and the shortage of the worker also. The number of the young worker is decreasing drastically due to special characteristics of maritime labor and other things. And also difficulty using service. The same as a railway, schedule is rigid and difficult to flexibility meets demand. So they have also possible suggestion, tax relief as an incentive for modal shift subsidies. Actually, the government conducting this kind of incentive subsidies and promote cooperation among operators, strengthens cost bargaining power to our shippers, training of workers, and information system, and other things. Well, then in this research, we should consider how to reduce CO2 emission in the transportation sector for the following the Japanese government policy, because government set a goal achieving carbon neutrality by 2050 by using political measures, regulation, incentives. So in this research, we can make a formulate decarbonization policies incorporate So using generalized cost function of shipper model choice, and also national scale transport network model, and origin destination analysis for domestic trade in Japan. Then simulate overall impact decarbonization policies on freight volumes of CO2 emission. And then we can evaluate these results. So here is a very technical matters, so I don't explain detail, but one point is how to make it average cost. So cost is a main part of the cost itself, average cost, but also we can consider variance because cost is not so not fixed always. Then there are change in negotiation. That's why variance of the root cost also considers. And the cost function, we have a cost function as a link of each. Link mean about connect to node in the road network or railway network. Node mean the station, or road case is an intersection, and the internal water case is a port. So then connect is a link. Then the link function, we can add it about the CO2 emission cost in the original formation. Original formation is other paper. And then the C means the shipper's consciousness parameter. How shippers conscious to reduce CO2 emission. Because normally, shippers just consider the cost and time only. But now we should, in the current situation, shippers also should consider to reduce CO2 emission. That's why we added about this consciousness parameter here. And CO2 emission per ton, per distance, and also price. Price is also we can consider flexible of CO2 emission per ton. Actually, price can be already is monetized in the Europe. Europe is an emission trading scheme. It's already implemented. So their price is, I remember around 90 or 100 euro per per unit. So we can consider such kind of the existing the price. And also cost function of the node. Node mean, as I mentioned, like station or port or seaport. So seaport terminal subsidies or station in the railway case, we are considering about this average cost in the any mode. Then one part of the accuracy, considering the accuracy, we are using the discretize in the all the territory in Japan. In the one dot is a shipper's location. Then shipper's location connect to the destination, and to showing using the roadway or waterway or railway link. And using the average cost function, the variance covariance matrix, we can apply for this for multinomial normal distribution, multivariate normal distribution to show port choice probability and showing the model choice results. And then finally, we can estimate freight transport by using Monte Carlo simulation. And one of the point of the scientifically point, so if we want the origin here to go to some Osaka here, Tokyo destination, they are overlapping the same road. In that case, normally if we calculate simply, the duplicated area is over consideration of the variance. So variance covariance structure can be reduced such kind of the overlapping consideration. That's why our model is more accurate. So the accurate estimation of the transportation cost. This is the scientific characteristics. Then we also making the network data. So origin destination data for the 900, almost 200 livelihood specialist area, extending only among prefectures. So we have 47 prefecture, but also we are dividing more detailed division as a zone. And then road network, railway network, and waterway network can be made by our existing database, from the existing database. And then the waterway particularly, we are separating the types from ro-ro, ferry, container, and trump because they have a different route in the sea. Then this is actually all four network, but in the DL calculation, there are different role. That's why we are considering the separately for estimation on the modal choice on the waterway transportation. Then we are having the three scenario to consider to reduce the CO2 emission. One is first scenario, as I mentioned already, shipper's consciousness, just 5 times. So current situation 1. Then how, actually 5 just arbitrarily decided. So how we can change about our shipper's consciousness. And the scenario 2, to add is a carbon tax, actually raising carbon tax 5 times. And the scenario 3, so subsidy the $5 per tonnage for port operating the ro-ro liners, because ro-ro is one of the popular waterway transport mode in Japan, and actually more volume than the container liners. That's why we are considering subsidy for $5 tonnage here. So then we can estimate what about involvement of policy makers and how Japan lays in tax in the future, and we can also discuss subsidy policy will roll out or move more ports. And the emission factor of each 3 mode, truck, the railway, and waterway can be followed for the Ministry of Land, Infrastructure, Transport, Tourism, their decision. Then here is the results, modal share. Scenario 1 is the modal share has not so changed from basic scenario to scenario 1. Actually, from here is just minorly slightly change from reduced truck and increase railway and trump, but it's not so almost no impact. Then what about scenario 2? Raise on carbon tax of 5 times, then railway share is increasing, and then decreasing truck, from shifting from the truck to the railway. And the scenario 3, subsidy to the ro-ro liners, and then ro-ro liners just increasing from the truck. So the cargo is shifting to ro-ro, and keeping this carbon tax, the railway, so still railway also high share, but its impact is highest impact is ro-ro to increasing. But in these 3 scenario, this clearly it's only 2% decreasing from the original truck share. So our actual calculation, we have a confidence it's very accurate, but that means the impact is very minor for this kind of policy. And this is a modal share volume. Then how much reduce the CO2 emission? So CO2 emission case, their emission factor is different. So the more than impact the modal shift. Modal shift is only 2% change, but it's scenario 3, 6.5% reduction from the baseline scenario cases. So it has been kind of significant decrease because more than 5%. And then this means the subsidy to ro-ro. So waterways emission is increasing, but more than 10%, but emission factor is truck is much higher than the waterway. That's why total emission reduction is very high from the compared with the basic scenarios. So here is a visualization of the link CO2 emission. For road network, yellow color and red color has the highest density. So CO2 emission impact, actually CO2 emission from Tokyo to Nagoya and around Osaka, Kyoto, Kobe, this is a high, and also like an expressway from the Tokyo to northern area and continue to the Kyushu Island, Fukuoka. This expressway and also some area in the Hokkaido Island, that is a road network CO2 emissions high. And the railway case is very clear. Actually, the same color, but the volume is very different from truck and railway. But railway cargo is very popular in the Hokkaido Island. So then the Hokkaido Island is the highest, the CO2 emission. And other area is a really minority. And the waterway cases, from Tokyo to Osaka and here, between Honshu Shikoku Island, we can call this is Seto Naikai Sea. So Seto Naikai Sea, they have a short distance, but this area is a waterway, particularly rural network, is very popular. And the other one is Hokkaido, Tomakomai Seaport. This here is a gateway seaport to the Honshu Island. That's why this area specifically, waterway network CO2 emission is the highest in Japan. Yeah, this is network results. And I think it is difficult to recognize, but also we can try to distinguish between basic scenario and scenario 2, basic scenario and scenario 3, how much differences from increasing to show in the network. Yeah. Then the results here, and very few increase in the shipper's consciousness and insufficient. And carbon tax increase can lead to increased utilization rate of the railway, and carbon tax with the inadequate strength waterway sector. But strong incentive for waterways are necessary. But modal shift not sufficient reduction. Furthermore, modal shift may not be sufficient measures as the road transport accounts for majority emission. So still majority of the emission. So the government considers another policy. And okay, before going to the next topic, so you can, if you want to interested in this topic, it's already published a paper. So please read about this paper, Journal of the Cleaner Production, published just last year. So here, then Japanese government, they consider the vision of Autoflow road. They say crisis opportunities through Autoflow road. So this is that's copy from the government material. So first, before I explain about the Autoflow road, I will introduce about YouTube video. Actually, voice is Japanese, but in the text can be shown in English. Okay, so we can start.
流の効率化ができます。また、自動物流道路において、物流の全体最適化、物流モードのシームレスな連携、カーボンニュートラルの3つの方向性を目指しています。では、東京、大阪間で自動物流道路を構築できた場合、トラックドライバー1日1.2万人から1.7万人の労働力に相当し、最大で年間 CO2 排出量を143万から193万トン削減可能と考えられます。我が国最大の大動脈である東京、大阪間を念頭に、2027年度までの新東名高速道路の建設中区間における2030年代半ばまでの第1区間での運用開始に向け、検討を進めていきます。
Okay, so this is a Autoflow road concept, and they translated about different way because directly translation in the YouTube. So Autoflow road is a new logistics system that transport goods using the unmanned automated transportation means powered by clean energy with a dedicated logistics space within the highway. So as already YouTube show video explaining, in Japan is a very seriously faces about truck driver shortage. The peak time is more than 20 years ago, in the truck drivers, so 2020. Then truck drivers deficient shortage. Then we call this is a 2024 problem because the Japanese government is so strictly regulation about the overworking time. Not only truck drivers, all the people, all the workers. Then the overworking time is 960 hours in a year. So truck drivers cannot drive with the overtime. So the driver itself is decreasing. Then the driving time also decreasing. Then this is one of the background. And the second background, as I already shown, the around 20%, 80.5% is transport sector in Japan is short emission, and the freight transport is 45%. So how freight transport, the transport emission can be reduced especially from truck. This is another issue. And also the packaging, as already mentioned, tonne-kilometers is stable because that becomes small volume, high frequency shipment is drastically increased compared to the past. Shipment cargo volume itself is very small, and the number of shipment is drastically increased. So how we can adapt such kind of the trend of the cargo? Then Autoflow road is proposed by the MLIT, our Ministry of Land, Infrastructure, Transport, Tourism, and 2 years ago, 2024 February. And this concept is road space to create dedicated space and transport goods using unmanned automated transportation measure and unmovable digital technology. So their name is the Autoflow road for using utilizing road space and utilizing digital technology to achieve unmanned automated transport measure. So one issue, how can they make a package? So they have a very small size package. So they can make the palletized image of the cargo, small one. So small volume, high class shipment should be using this one pallet for then they can treat this cargo easily. And the target area for this Autoflow road from Tokyo to Osaka. As I shown in this is a high density cargo area by using the expressway. So aiming implemented by 2030, next 4 years, Japanese government would like to start this new system. And then last year, they established a consortium. So three aspects of the committee, three way of the committee. So one consortium has business model subcommittee and operation subcommittee and the infrastructure subcommittee. Because in the commercial aspect, business model is very important. Otherwise, private companies do not invest such kind of the new technology. So business model subcommittee considering how invite the private company side for investing this new technology. And the operational subcommittee So how we can they set about the demonstration experiments, particularly for technological aspects. So their operations side and the infrastructure subcommittee for how they improve the expressway, because this is on the existing expressway or expanding existing expressway. So infrastructure, road, highway infrastructure also can be modified. So that's why they need to consider about this subcommittee. So these three committees are established, and from last year to this year, they are discussing the several experiments and several phases to go to realize this new system. And here is a many texts, but what they say is about role of the Autoflow road. The one part is optimization for entire logistics system, standardization and automation. So standardization is the palletized, and the flexible transportation planning. So they don't need to using the truck drivers, but truck drivers. That's why 7 days operation Autoflow road is possible. And another form, the transforming business practice is improving working condition. So how they can reduce truck drivers' burden? This is also one optimization entire logistics system. And the seamless integration logistics model for not only considering among the any different transport mode, but only also in the truck transportation, in the government, another project, the truck platooning. So truck platooning mean autonomous truck connected the 3 or 4 autonomous truck connected in the one platoon. So their first truck is a driver, but second, third, fourth truck is no driver. So they are parallelly discussing about this truck platooning. So truck platooning also collaborates with autonomous Autoflow road. Yeah. And also, as I mentioned, carbon neutrality. So this is also important part. So based on this, the road flow law collaborate with several actual purpose, then collaborating for another transportation mode, then they can achieve for their main purpose to reduce to utilize about truck drivers issue and also reduce the carbon emission. Then required function Autoflow road is here about target area is Tokyo, Osaka already, and the several hub set up, multiple hub in the intermediate points. And the cargo shape, then standardized inspection pallet, and the speed. Speed is one of the important issue, targeting 70, 80 kilometers per hour. It's very fast. So they are considering this speed and accident advantage, other thing. So they have already received many proposals from the private companies, how they can using this system in the tire mounted cart or linear motor based two-dimensional cargo system by a few private companies. And the infrastructure side, as I mentioned, they have several functions like interchange, junction, service areas, and parking areas. And relocation, underground utilization also they need it. And then also shoulder slope can be also the changing. So they road to space is the existing expressway from Tokyo to Osaka. How they can use the space utilization concept, because their existing car is here is already and driving. So central area is in the video they show only central area, but also considering the edge area, right hand side, left hand side can be also considered the space. Then the effects of Autoflow road, as the number is different from the video, but they say in the slide, they say that truck drivers reducing the working hours 20,000 to 56,000 person days decreasing, Then CO2 emission reduction also 2.3 to 6.3 million ton CO2 per year. So this is the how to say how big reduction on the CO2 emission from the existing compared with the existing situation. Yeah. So then capacity autoflow estimated condition under this calculation, the around 500 kilometer, and then finally they can estimate such kind of achievement. Yeah. And also, of course, they have some risk for the construction side, high cost, cost uncertainty, and funding risk. It's not fully supported by the government. They also expect about private funding, and then funding risk also including here, and the operation uncertainty of the demand. Even government promoted the how because cargo transport is really private operation. That's why the shippers and also transport operator attract to this system. So uncertainty of the demand also problem, risk operation and unpredictable business model and some other stuffy other things. And the maintenance matters, deterioration, outflow in the future, and the road funding and damage and the possession issue is also as a considered risk. Then the video already shown. Actually, this year's January, February, March, they have several experiments already done, like have streaming cargo handling operation, like here, and roadway section, conveyance equipment operation, very short distance they have done already, and roadway section, abnormal condition they test. I think they did already. And the use case for road section communication, Wi-Fi connection, it's already done in the February. And the transport equipment operation management, I think they did not yet. And have a provision information arriving schedule. This is not yet. So in the several the experiment has already been done in the January, February this year. So they have a good progress about to start in the 2020 2030. And this is the final slides. In the government, in the bid, the experiment should be finished by 2027 next year. So this year also experiments, next year also experiments. Then 2028 to mid 2030, they are considering to start in some small distance area. And midnight 2030, they are fully operation from Tokyo to Osaka. Yeah, so this is all my presentation. Thank you for listening. Thank you very much.
Thank you very much, Professor Hanaoka, for the very insightful presentation. So now we have some time for Q&A. We've received some questions already from our participants. So maybe I think there were a number of questions. The second portion of your presentation on the Autoflow road concept, I think, was quite interesting. So there were a couple of questions on. Let me just read them out here. Does the Autoflow road concept reassign, and I think it's mentioned a little bit in terms of what the thinking is, does it reassign existing road spaces, such as taking some of the lanes off in terms of general traffic, or are they thinking about constructing new lanes? In addition, I think you already mentioned some of those points. And in terms of use of new technologies, such as drones, in terms of delivery of these small packages, would that play a role? And one example was in the US, a truck delivered goods between Houston and Dallas without a driver. So they noted that driverless trucks could also address some of these issues in terms of driver shortage. So is this something that maybe could be linked with the auto flow road concept that could provide, similar benefits without necessarily needing additional road space? There was another set of question, I think, on this, and I just maybe share them with you already. Your thoughts in terms of Autoflow water instead of autoflow road, whether this is also something that's being considered. So looking at waterways instead of, I think, roads. So if you have any thoughts on this aspect, I think we got one question from Kondamuru from India. The government of India is prioritizing inland waterways given the availability of rivers and less freight cost. So maybe you can share some of your thoughts on those set of questions.
Well, I can catch about second, third one, but the first one is a long question. But can I reply from the second, third one first? Yeah, autoflow water's idea. Well, actually, in the autonomous vessel has already developed, and in one company in Japanese vessel company, they have already started experiments. So autoflow water in this case, and we can consider about the specific water corridor can be developed. But the first, I think it's not so it's difficult. I'll say not so easy to specify about corridor because a waterway is really affected by the climate situation, weather condition. So they often change about the using the route. So autonomous vessel is possible, but autoflow waterway might be the bit difficult to implement. And the third question is the waterway for what is the exact question? What waterway? Can I
Sure.
know?
So the first set of question was on whether the autoflow road would reassign or take up existing lanes that's specified for road traffic, or would it involve constructing new space, and how you think it would link with the new technology in terms of driverless trucks, whether that would also support similar type of outcome that the autoflow road concept wishes to achieve.
I see. Okay, thank you for your question. Yes, in the between Tokyo to Osaka, we call the expressway name is particularly between from Tokyo to Nagoya. It's around 350 kilometers. We have a same name, the Tomei Expressway, but there are first Tomei Expressway and second Tomei Expressway. Then they can use the government can consider to use about second Tomei Expressway for Autoflow Road. So during the construction time, the first Tomei Expressway is open, so there's no conflict between the existing truck and the passenger car and construction. And then actually land acquisition in Japan, this area is really difficult now. So expanding the network, it might be not so easy. So existing in the expressway, so 6 lane of the first Totome Express and also 6 lane mean about one side is 3 lane. Then they can, I think second expressway for the intermediate part can be removed from the lane. Then they established they set about the Autoflow road. Yeah.
Thank you, Professor. And maybe I could just also add, and if you could share your views, the concept seems very aspirational and very interesting. Of course, it might have a lot of resources that would be needed, and it's still at, I think, at initial stage. And as you presented, it's targeting to be operational sometime in 2030. For countries in developing Asia. What elements of that concept? You've mentioned they were also looking at business model, operations, infrastructure. What elements of an autoflow road concept do you think could be relevant or transferable for countries in developing Asia?
Oh, I see. Wow. Okay, okay. Interesting question, but difficult question. Well, it's a needed for the basic infrastructure. Yeah, that's why the one of the most important point. So if this developing country, they have a good conditioned expressway, then they have the how the implementation possibility is much higher. But if they have no such kind of expressway for long distance, in that case is a big obstacle to implement the auto road. Because before that, this country should construct about the large scale and long distance expressway network. Yeah. So infrastructure bottleneck is one of the
Major
most important.
consideration.
Yeah, major concern.
And we received another follow-up question. I think the autoflow concept is very interesting. So they've mentioned that autoflow assumes 24-hour unmanned operation, clean power supply, and also stable communications. So for countries with frequent typhoons, for the Philippines, for example, or other countries that experience a lot of typhoons, monsoon flooding, grid instability, or weaker cyber capacity, what other possible challenges should be considered when exploring this type of concept, and in the design process as well.
I see. Well, okay, because this is technological aspect. Yeah. I checked about their material in the more detail in Japanese language. They said about this kind of typhoon on the well as a disaster, the flood. They may use the dome for protecting from the strong window. So then they can protect the cargo. So this is one idea. And also another idea, I remember Switzerland, they are considering about underground similar concept. So in some area, this autoflow road is not only the on the ground, but also underground can be one for protecting from such kind of disaster. Yeah. But
Thank you.
underground is of course a very high cost. So they are considering the balance, how we can protect from such kind of risk and also high cost.
Thank you for that. I think we also received, I think, some insights from Brendan in the Q&A. There's been some pilots for catenary wire expressway in Germany for EV trucks. It seems could be a cheaper solution and a more efficient use of expressway space to follow this approach with autonomous trucks. Also takeover of hard shoulder and central areas could bring safety and access issues. So thanks for sharing these thoughts. There was also another question, I think, from Aftab. Will the autoflow vehicles run? Will they be EV vehicles? What will be the source of electricity? I don't know whether this is something being considered in the Japan concept, Professor, that you could also share with us.
Oh, this is a free EV, yes, electric vehicle. Yeah, yeah, you're right. Yes.
Okay. So let me just check if you have any remaining questions. I also actually wanted to check with you in the first part of your, first part of your presentation. You've also, I think, mentioned that the results of the analysis, that's not enough to just have the carbon pricing and also environmental awareness of the shippers. These measures lead to very modest decarbonization in the freight sector. So, how should governments adjust their strategy if they're primarily focusing on modal shift for their decarbonization policy for this specific sector?
Yeah, it's a nice question. And yeah, we are often discuss about this issue. How we can shift it from the truck to the railway and the waterway in the last 20 years. And one issue it's a expressway is trucking cost is still very low. Yeah, it is actually the already highway companies is not already they privatize around 20 years ago. So after privatize, so they want to utilize about road. So the daytime is also passenger car is there, but nighttime is no passenger car. So they want to utilize this time is a truck. So it's government do not strictly control by this kind of their business model. So and the nighttime driving is also actually efficient for the shipper side because they can give the cargo from the how to say in the hub area and nighttime to moving to another area, and it is efficient for this. That's why difficult to stop the truck transportation in Japan. So then yeah, incentives, tax, the pricing, and subsidy is partially they already possible implementation, but there's no other good ways. That's why Autoflow road or other technical the innovation or innovative idea, this might be the expected to reduce the short emission.
Thanks, Professor. Actually, I also wanted to ask, 'cause I'm coming from, I work on air pollution. So I saw this one study by the Asian Transport Observatory that noted that while many countries promote the shift from road to maritime transport as a low carbon option, this has also, in some cases in Asia, contributed to increased local air pollution due to high sulfur fuels that is used in domestic shipping. So, what do you think could be options in terms of countries to balance and align their decarbonization strategies with local air quality objectives, specifically within the freight sector?
Okay. Well, the probably one issue about the short distance kind of urban area case and the long distance case. Yeah. So in Japan, it's already long distance utilizing the waterway. So then if you consider the model shift from the long distance case, you can promote about railway or waterway. It's one of the things. But as I show in the cargo type is becoming the smaller, becoming the e-commerce developed. So the urban area case, more technological change like introduce electric vehicle free truck or automated the car truck introduced inside of the urban area. Yeah, this kind of the new idea in that or specific experiment area you can try for this kind of technological idea for autonomous truck or no drivers cargo system for by the delivering by small robot. This idea can be the one of the good way.
Okay. We have
Yeah.
two last questions, I think, and I think we'll need to close the webinar. I just wanted to also check with you if you could quickly share with us what policy instruments could shift shipper consciousness based on some of the experience you have in Japan, disclosure mandates, green logistics, etc. Which ones had a measurable impact in Japan?
Which one among the?
Some of the examples were disclosure mandates, green logistic labels, public procurement preferences, or other types of instruments that worked in Japan to shift and improve the shipper consciousness for decarbonization.
I see. It is yeah, I have no good this is so to change about their consciousness.
Yes.
I think the changing the kind of the pricing for the decarbonized products. That's kind of the more economical incentive for the more impact to the shippers consciousness. Yeah.
Okay, thanks. And then finally, a question from Marionel. Autoflow is a very good model. Can you briefly share how the unmanned truck is controlled, speed going to the highways, etc.?
Yeah, this is unmanned truck. It's unmanned truck is yeah, as I mentioned, the platooning is already discussing. So unmanned truck itself is not developed yet, but the truck platooning case, this is a driver's truck, but they don't need to use the drivers. So unmanned truck is control speed going to into the highway. Wow, yeah, I'm not sure that this question is the Autoflow itself, because Autoflow itself is there's everything is a no driver and the small size of the vehicle. Yeah, and they can control the centralized area. So that is one is idea in the several centralized area in the control terminal. I don't know how to call it. Yeah, this is their idea.
Thank you. And I'm hoping that we'll find out more once the results of some of the testing for the concept is being developed leading up to 2030. So I think with that, I'd like to sincerely thank Professor Hanoka for sharing your insights and walking us through Japan's experience in decarbonizing freight transport. Thank you so much for your time. Really appreciate it. And also accommodating all of our questions from the participants. And we hope to see you again in the future Green Roads webinar. So as we conclude, just a few announcements. Please take a moment to complete the webinar evaluation form by scanning the QR code on the screen and also clicking the link in the chat. Your feedback helps us improve future sessions. You can also join the Green Roads Community of Practice to receive further updates on the Green Roads Toolkit and other webinars that's being organized by the team. The recordings and all of the presentations from this webinar and also past webinars are available there in the ADB Knowledge Events page. And finally, we want to warmly invite you to join us at the Asia Pacific Transport Forum 2026. This is ADB's flagship transport sector event with sessions on green roads and other areas of priority under the UN Decade of Sustainable Transport. The forum is taking place in a couple of weeks, 19 to 22nd of May, at the ADB headquarters here in Manila. The registration is open until the 11th of May, and you can join via the QR code on the screen. You can also visit the website at transportforum2026.adb.org. Thanks so much for joining us today. We hope to see you at the Transport Forum or at future Green Roads webinar. Have a nice day. Thank you, everyone.
Thank you. Bye bye.